I'm Anil Kumar, sharing with you a series of videos on data analysis and sampling techniques. We'll divide this topic in mainly two parts. One is data analysis. The second one will be sampling techniques. In part one, we'll discuss about data analysis with graphs, histograms, bar graphs, frequency polygon, cumulative frequency graphs, relative frequency distribution, and circle graph. In part 2, we'll discuss how to identify a population, understand different kinds of biases, and then few sampling techniques. Some of them are mentioned here. Sampling techniques like random sample, systematic sample, stratified sample, cluster sample, multi-stage sample, voluntary response sample, and convenience sample. I've taken up questions from previous test papers, so we'll discuss part 1. It will be series of videos. We'll combine few in one video. So the idea here is to take some questions from previous test paper, like one here, and then we'll type out the question. We'll use the same kind of data to construct different kinds of graphs and then analyze and understand the techniques, right? So from the test paper, here is the very first question on data analysis. The question here is, a teacher surveyed his students. He asked them on a scale of 0 to 12 hours per week inclusive, how often do you do your math homework? Their responses are shown below. Now from this data, you have to construct a frequency table, construct appropriate frequency graph, what proportion of students did an acceptable amount of homework if the teacher believes a student should do at least 1 hour per school day, right? So that's the kind of question which we are going to answer, right? Now we'll actually modify this question a bit, saying that, let me reposition the page. Keeping the same data, redisplay the data in grouped format, remove outlier to allow for grouping, construct a frequency table for these data using group data, construct the associated frequency polygon, and cumulative frequency graph. So you'll get to know how to construct these types of polygons and graphs, right? Then we'll have a question based on categorical data, and we'll construct a circle graph from here. A statistician wants to see the trends in calculator brand purchases for senior level data management students at the local school over the past 10 years. He has his data, so that's the data for 2005 brand use and 2015 brand use. You need to construct a circle graph for both years and then analyze your data. So that's what you'll be doing. So with that, we'll understand how to construct a circle graph, right? So I hope with this, we'll be in a good position to cover most of the topics of data management, which we talked about in the very beginning. So here's the very first question. A teacher surveyed his students. He asked them on a scale of 0 to 12 hours per week inclusive, how often do you do your maths homework? Their responses are shown below. Construct a frequency table for the data. Construct the appropriate frequency graph. What proportion of students did an acceptable amount of homework if the teacher believes a student should do at least 1 hour per school day, right? This is 1 hour per school day, and the data is for 0 to 12 hours per week, correct? So that is the question for you. You can pause the video, copy the data, analyze, and then look into my solution. Now, whenever we have raw data, it is good practice to make a tally chart and then a frequency table, correct? So the first question here is construct a frequency table for the data. So that's what I'm going to do now. So my method is going to be slightly different than normally done. So I'm not making a tally chart. Straight away, I'll write down the frequency since the data is not that large, correct? So here we are counting hours per week, right? And here we'll write the frequency straight away. So the lowest value is 0, the highest is 12. So if it is 0, then we have 1. If it is 1 hour per week, then let's count the number of ones here. That's the whole idea. So what you have to do here is basically count. So in counting, what we will do, so let's count number of hours here. To be sure that we have taken care of all the numbers, we'll strike out the numbers counted. So we'll first count the number of ones. Instead of making a tally chart, I'm just counting directly, right? So it is 1, and then we have 2, 3, and likewise, like we got 4, correct? So I'll write the number 4 for number of ones, correct? Now we'll count how many 2's are there. So number of 2's is 1. So you can go in a sequence. 2, 3, and 4. So we got 4 2's. Number of 3's. 1, 2, 3. So we have 3 3's. 4. 1, 2, 3, 4, 5, 6, 7, 8 4's. 5. 1, 2, 3, 4 5's. 6. 1, 2, 3, 4, 5, 6, 7. So we found 7 6. 7. 1, 2, 3, 4. 8. This may take time. 1, 2, 3, 4, 5, 5 8's. 9. 1, 2, 3, 4, 5. 10's. 1, 2, 3, 4, 5. 11. So 1, 2. 12's. Okay. 1. 2. So you get 2. 2 12's. So I hope I have taken care of all the numbers. We can actually see how many numbers we have taken care of. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we expect 54 in all, correct? So let's count. It is good to count and check. So 1 plus 4 is 5, plus 4, 9, 10, 11, 12, 20, 24, 31, 35, 40, 45, 50, 52, 54. So that's perfect. So I think the counting is correct and we have taken care of all the numbers, right? And now at this stage, we can construct appropriate frequency graph. Now, what do you think is an appropriate frequency graph in this case? Now, as you can see, it is all integers, correct? So we'll call this as a discrete data. Perfect. Since we are treating this as a discrete data, a histogram could be good, right? So the options here is histogram is a good option, right? We can also make a frequency polygon. That's not a bad option. Frequency polygon is good enough. So these are good for discrete kind of data. Now, next question here is, what proportion of students did an acceptable amount of homework if the teacher believes a student should do at least 1 hour per school day? So when we say at least 1 hour per school day, that means 5 hours per week. Is it okay? So acceptable is 5 hours per week, 5 included. So in this particular criteria, acceptable number of students will be all this, 5, 6 to 12. Perfect. So the percent you can find by counting these numbers, divide by 54, and then you get this answer, correct? So these are short answers. Let me start from the last one itself. So how many are there? We can just count these. 4 plus 7 is 11 plus 15, 20, 25, 30, 34. So as far as these are concerned, it is 34 over 54 times 100 in percent. Is it okay? Or you can also say 34 out of 54. That is also correct, because it is saying what proportion. So what proportion we can say 34 is to 54, correct? That's perfect. If you want to calculate percent, you could do, which I don't think is necessary, but it's not a bad idea, since normally ratio is also out of 100, right? So it is around 63%. So that gives you around 63%. So that becomes the answer for the last question. Now, why I did so is, in a test paper, you know, most of the questions are kind of equally marked. You'll take a lot of time in making histogram and all those things, correct? But these are straight questions which could fetch you marks at the earliest. So we got marks for all this. Now we are left with sketching the frequency graph or a histogram or a frequency polygon, correct? So let's do that part. I'll make rough sketches here, and I hope that will work for me. However, you need to do a better job, right? So we'll have a scale here. Okay, so I have to put in 12 numbers, correct? So I'll try to squeeze them in. What I also see from the given data, that the number goes maximum to 8. So on a scale, I say this is my 1, this is my kind of 2, right? 3, 4, 5, 6, 7, 8, right? That makes sense, right? So we have here the numbers, which is like 8. So we have 1, 2, 3, 4, 5, 6, 7, 8, correct? Now let's construct our frequency diagram. Let me do it in some dark ink. Okay, so, or a bar graph. So if I make a sketch which is kind of like this, let me show you. So for 0 it is 1. So if I make a sketch like this, it becomes a bar. Do you see that? At 1 it is 4. So at 1 it is 4. So I'll just make it like this. So 1 it is 4. And then at 2 again it is 4. At 3 it is 3. So it is a bar here. Then at 4 it is 8. So at 4 it is 8. 5 it is 4. So 5, 4. At 6 it is 7. So it is 7 for 6. At 7 it is 4. So it is 4 for 7. 8 is 5. For 8 it is 5. Is 5 for 9 and 10 also. And 11 and 12, it is 2. So I kind of squeeze them in, right? I could have gone wider than this, right? So what we have here are our numbers. So we have 0 here. Let me write the numbers like this. And then we have 1, and then we have 2, we have 3, we have 4, 5, 6, 7, 8, 9, 10, 11, and 12. I could have spread them out. Anyway, you understand the technique. Now, if I do like this, then what we have on the horizontal side is number of hours. So let me write down here number of hours per week. Is that okay? And we should write frequency. It's very important to label, right? So you have constructed your appropriate frequency graph. That is very important, right? Now you could make this as a frequency polygon also. So if I want to make a frequency polygon, what should I do? I just pick these midpoints and join them. So it becomes a frequency polygon for discrete data. This is a good technique, correct? So let me just join them with red ink. So we can just connect these points. So that gives you kind of a trend. And what you observe here is that most of the data is concentrated in the center. You see that? And on the sides, we have got lesser number of hours as expected in kind of a normal graph, right? So that becomes a frequency polygon. So once I connect them, it becomes frequency polygon. So I hope with this you understand the technique of creating a frequency table, making a tally chart basically, and then representing it in the form of a graph for discrete data. Histogram or a frequency polygon as shown here is a good option. Perfect. Now we'll move on and take the next question. We might have to refer back to this since this useful work done. See, I have actually copied the same data so that I don't waste my time in counting all these numbers over and over again, right? So we might get back to this again. The next question here, which is very much related to the first part we did, is redisplay the data in grouped format. Remove the outliers to allow for grouping. Construct a frequency table for these data using grouped data. Construct the associated frequency polygon and cumulative frequency polygon graph. You get my point. So that's what we have to do. So this time what we have to do is we have to group the data, but before that we have to remove the outlier to allow for grouping. So that is important criteria. So whenever you group data, you have to remove the outliers. So in this particular case, I'll consider 0 to be an outlier. So I'm going to remove this from the data. Correct? Number of hours studied per week is 0, and that is not acceptable to the teacher also. So we'll remove this. Now, based on this, we could have asked one more question, is that what kind of bias is there in this kind of a question, correct? So that's a very important question which you should also think about, and how we could have changed the questions to avoid that bias, right? So that is what you should also think while working on this. So to give you answer for that, give the response anonymous without writing names, just a slip. Then we could have removed the bias and got a better data, right? So that is what could be your answer for that. Okay, so let's move on. So what we did in part 1 was that we just constructed a frequency table. So I'll actually copy that table here and begin from there. Since we removed 0, we'll begin with the numbers 1, 2, 3, 4, right? So we have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Correct. So I'm copying the frequency for these from the previous table, which is this place, right? So we'll start with 1 to 12. It is 4, 4, 3, 8, right? So, and the rest. So we have 4, 4, 3, 8. And 5 onwards, it is 4, 7, 4, 4, 7, 4. And we have 5, 5, 5, 2, 2, 5, 5, 5, 2, 2. So that was the frequency which we calculated just now. We are also talking about cumulative frequency polygon graph. So let me add a column for cumulative frequency. Right? So cumulative frequency is just keep on adding. It should add to 53, right? We removed 1 for 0. So that gives me 4. And then 4 plus 8, 4 is 8, 8 plus 3 is 11, then we have 19, plus 4, 23, plus 7, 30, plus 4, 34, plus 5, 39, plus 5, 44, 49, 51, and 53. So that's correct. Now, we'll talk about grouping the data. So whenever you want to group discrete data, it's a good practice to first consider how many groups you should have. The range is from 1 to 12. If I divide by, let's say 3, I get 9 groups. So we could make 9 groups. 5 to 10 is kind of acceptable, right? Now, how do I make this kind of continuous data so that we could make a bar graph, a histogram, right? So when we talk about constructing frequency table for these data using group data and construct associated frequency polygon, I'll actually also make a histogram. Let me add that here. So for a group data, histogram we are going to make, and then joining the middle values, we get frequency polygon. Perfect. That's what we'll do. Now see, how do we create group data from here? We can consider the groups of these 3 each. Do you see that? So you could consider the groups of these 3 each. Now, to include them, I could have an interval which is from, let's say, 0.5 to 3.5. And then from 3. Let me write here now, 3.5 to, keep on adding 3. We have taken an interval of 3, right? So 3 to this will give me 6.5. And then we can have 6.5 to 9.5. And then 9.5 to 12.5. Does make sense. So that way, we now have intervals of 3, correct? And from here, we can always see the mid values and then sketch our grouped diagram. Is it okay? So we have a score. We have this number of hours interval. So let me call this as a class interval. So we can say group interval or a class, or let me say interval. Now, this means these 3, correct? So number of students in this category is 4 plus 8, 12, 12 plus 11, 23. So we can write this number 23 here. So that becomes the group frequency, correct? And then in this group, we'll combine these 3 terms. So let me use calculator. I'm sorry, I had to add the frequency. 4, 4, and 3. That's good, yeah. So 4, 4, 8. 8 plus 3 is 11. Sorry, this is 11. So we are basically adding, that is the frequency, right? So this 3, great. Okay. Then we have 8 plus 4, 12. 12 plus 7 is 19. 19 here. Next one, we have 10 plus 4, 14. And then we have 5 plus 4, 9. Right. So with this, we know how many in each. Now let us construct our table. So let me do this table here. So we have from, let's say 0.5, 3.5. So we'll write these numbers. Let me push it a bit. There, correct. So we could write this as from, we'll make a histogram first, 0.5, then we have 3.5, 6.5, 9.5, and 12.5. Perfect. Now, from 0.5 to this, we have numbers like 11, 19, 14, and 9. So let's say we go with 5s. 5, 10, 15, 20. Perfect. So when I say 11 in the first group, so it is from 11 is 5, 10. This is 10 for us. This is 20. So slightly more than this, right? So we go from here to this place. Then the next group is 19, so it goes up to almost 20, right? So, I mean, slightly lower than this, okay. 19, then we have 14, so here. And then we have 9, so lower than this. You get an idea, correct? So when you fill this up, it becomes a histogram representing the group data. Perfect. Now taking care of the middle point, which is in these cases, so we say midpoint. So here it is, you can just add, divide, 4 divided by this is 2, and then keep on adding 3 to this. 8 and 3 is 11, correct? So at these points, which are like 2, 5, 8, and 11, right? So we have these points. We mark their center values. And if you join them, we get frequency polygon. You get an idea. So this becomes your frequency polygon. So we have constructed both histogram and frequency polygon in the same graph. Now let's talk about cumulative frequency polygon graph. Now normally, because this has been combined with the grouped data, normally we prefer to write cumulative frequency polygon separately. So cumulative frequency column is right there. So what you need to do is construct another graph for the cumulative frequency. Since I don't have much space here, what I will do is kind of sketch it in one corner and just give you an approximate result. So what you need to do is, we know we are going up to 50, right? So we can start with 0, and then let's say this is like 10, 20, 30, 40, 50, correct? Now on the vertical side we have cumulative frequency. And here we have the number of hours per week. So if the number of hours is 1, then it is 4. So these are like 5, 10, 15, 20. So if the number of hours is 1, it is 4. And then if it is 2, it is 8. So it goes to, let's say, 8. And then it is 11. So this is slightly more, 10, 11, 5, 10. And then it is 19, so slightly less than 20. And then 23. So basically, you have to get these points, correct? Then 30, so it is 5, 10, 15, 20, 5, 10, 15, this is 20, 25. Okay, so I think we started with the 10, 20. Let me redo this. Let me write the numbers. We have 10, 20, 30, 40, 50, and let's say this is 60, okay? So we'll go with that. Perfect. So those dots are the cumulative frequency dots, which is this point. So to start with, we'll start with 4. So initially, we'll say this is 5 for us. I'm redoing it. I'm making scales 10, 20, 30, 40, 50. So for 1, it is 4. And then it is 8. So it is slightly less than 10, 8. And then 11, more than 10. Okay, 11. And then 19, which is slightly less than 20. 23, which is between 23. 30 is there. 34, so it is midway. 39, less than 40. 44, midway. 49, slightly less than 50. 51, just above 50. 53, slightly more. That's the end of it. So what you see is this trend. Do you see this? So this is your cumulative frequency diagram. Perfect. So with a rough sketch, and I hope you get fairly good idea about how to do these graphs. Perfect. So with this data, we were in a position to show you how to make a bar graph, a frequency plot, and then grouping the data, we could make a histogram. Without grouping, I made cumulative frequency. We removed the outlier to do all this. Correct? So I hope with this you get good information about how to use these kinds of graphs to represent raw data given in this example. So we'll now take up a circle graph where we'll have data which is kind of representing different categories. I hope that helps. Thank you. So I've taken another question from previous test paper. It is based on data analysis, and we are going to learn the technique of drawing circle graph with the help of given information. The question here is, a statistician wants to see the trend in calculator brand purchases for senior level data management students at the local school over the past 10 years. He has this data. Now the data is for 2005 brand use and 2015 brand use. The brands are T, S and C, correct? You can pause the video, copy the question, and then you have to do this. Construct a circle graph for both years and then analyze your data, right? So that's the question for you. So what I've done here is just made some room, copy the same tables on the next page, and then from here we'll kind of make a table and construct a circle graph for both the years and then compare them, correct? So let us now count the brands for each year. So first one, let's talk about the brand. So we have T, C and S, right? We have these three things. So what I will do here is make a table here. So we can say the brand T, brand C and brand S. So in this table, we'll count and write the numbers for first 2005, and then we can do for 2015, and then make a circle graph. To count, what I'll do is we'll just strike out the numbers, and we'll strike out the brand names and just count. So T, we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we get 20 number of T's here. As far as C's are concerned, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We get 14 C's. And as far as S is concerned, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The total is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. We need 50. So 15, so we have missed something, right? So we have missed one here, right? So it is 16. Perfect. So you see, it helps. So when you strike it out, you can easily see what was not counted, correct? And clearly from here, what we have is total is 50. So out of 50, we got these numbers. So let me rewrite these numbers. For 2005, let me write 2005. Number of T's is 20, and then for C we have 14 and 16. And all this is out of 50, right? So this is out of 50. So as far as the percent goes, it is twice this, right? So it's easy to write 40%, this is 28%, and this is 32%. Perfect. So that is for 2005. The idea is to make a circle graph. So in a circle graph, based on the share in the market, what we are going to do is we are going to represent this on a circle. So in a circle, there is a total angle of 360 degrees, correct? So total angle is 360 degrees. This is 100%. So if I multiply each of these by 360, right, and divide by 100, I get the angle through which we should represent this category of data, correct? So that is to say, I have to multiply each by 3.6. So let's find the degree now. So let's find the degree in this table. So to find the degree, we'll do 40 times 3.6. So we get 144. So for the first category, it is 144 degrees, correct? When I say 28 times 3.6, we get in decimals 100.8 degrees. Let me call it 101 degrees. And 32 times 3.6 gives me in degrees 115 degrees, let us say, right? 115 degrees. So in all, that is 360 degrees. Perfect. So if I construct a circle, let's say that's my circle, to draw the circle diagram, then in this particular circle, I have to represent TC and S with these degrees, 144, 101, and 115. So what I can do here is, we know this is 90 degrees, 10 more is 101, 110. Okay, 10 more is 100, 90 plus 10 is 100, correct? So 10 more is that, and this is 15 more. So I could construct one, let me say, we'll do these two first. So that is 90, right? And if I do 10 more, I get C category. So that is, let us say, 9 portions you have to divide in. So 10 is very close to this. Does it make sense to you? So that becomes C for me. So this is C for me. Correct? Now 115 is 10 more than this, so could be like this. Does make sense to you? And that becomes S for me. So I could write this and make this kind of a shade here. So it's just color to represent it. And the remaining will be T for us. So I have a circle graph which represents 2005 brands. Perfect. We are going to do the same thing for 2015, and then we are going to compare them. Correct? So let's count first. So again, we'll count for T, C, and S. So for T, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, right? So we have a number which is 17. C, 1, 2, 3, 4, 5, 6, 7, 7. So let's write down 7 here. And for S, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we are saying 15 here. The total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 40. We need total of 40. Something is wrong. Did we miss something? So that's yeah, we have missed one S here. You see that S? So we'll mark this and increase S by 1. That becomes 16. You get an idea? So total is 40 here. Perfect. So this technique is very good actually. If you miss something, you can get back to it without wasting much time. So let's construct percentages for the second, which is 2005 branch for TCS. So what we observe here is this is 17, this is 7, 16, and all this is from 40. So if I have to write percent, I have to divide by 40 multiply by 100. So it is 17 divided by 40 times 100. Okay. In percent, 42.5%. Now 7 divided by 40 times 100 is in percent 17.5%, and 16 times, I'll do times 100 and then divide by 40, that's okay, is 40%. Now let's write them in degrees. Since it is 360 degrees, we are going to multiply by 3.6. So we'll start from here. Times 3.6 in degrees is 144 degrees. 17.5 times 3.6 is 63 degrees. And 42.5 times 3.6 is 153 degrees. What you clearly observe here is that there is a drastic increase in S. Okay, because it goes from 115 to 144, so this is going up. As far as C brand is concerned, there is a huge drop. There's a huge drop in C. It drops from, let's say, 100 degrees or 28% to 17.5%. Do you understand? 28 to 17.5%. Huge drop. And there's a minor gain for the brand T, which gains from 40% share to 42%, right? So 8% gain for S, 2%, 2.5% gain for T, and a drop of combined for C, right? So the market share for C has been decreased in these 10 years. Perfect. So let's again draw the circle graph. We have already calculated the percentages and we know the angles. So I'll begin with drawing C and S. C is now 63 degrees. So there's 90 degrees. When you partition into 3 equal parts, you get 60 degrees. So slightly more gives me 63 degrees. Does it make sense to you? So this is what I get for C now. So that is C now. Okay, so what we have here is the C for 2015. As far as S is concerned, its market has increased, and in degrees it will be 144 degrees. That means this is 180, take away around 40, right? And combined is more than 180. So this graph, let me draw it in red, will be kind of like this, right? So we have S here. The remaining is T. So I hope it's very clear how to sketch the graphs. And from the circle graphs, we can easily see that there has been a considerable gain in band C and a considerable loss for band C. Do you see that portion? Minor gain by T, right? So you can see by the area, it has increased a bit. S has gained major in this particular scenario. So a circle graph gives you a fairly good idea about the categories sharing the whole or comparing one to another, right? So as compared to C, S has become much bigger market. Earlier they were almost same, right? Slightly advantage to S, but now there's huge advantage, as you can see, right? So I hope you understand how to represent your data so that you can draw meaningful results. So I hope that helps. Feel free to write your comments, share your views. So with that, we end our part 1 on data analysis. In part 2, we'll discuss sampling techniques. I'll provide you a list of few more examples as separate videos to practice. If you like and subscribe my videos, that'd be great. Thank you and all the best.